Next, the last thing is importing cborn as SNS. That's it, right? So let me again brief you that yesterday we saw something that if like for loading any data set from the cborn, we use which function? Anyone could say function name? Quick. Anyone remember the
SNS.load dataset.
Yes. So the function name is load dataset. So we use load dataset function for loading any dataset, right? So let's load. Okay. So before going to this, one thing more is there. Right. One more thing is there. If we want to check what are the datasets over there, that how we can go for that. How many datasets are there to work on? Like to let's say 4.
The dataset name.
Which function? Dataset name.
Get dataset name.
Get dataset names. Get underscore dataset underscore names.
Yes, sir.
Right. Code. So let's see first all the data names. Right. So print, and then you write the library. Sorry, the package name. Get dataset names, and these are the names of the dataset particularly. So for loading any dataset, we use load underscore of dataset. So we are going to take one of them, right? So let's bring the tips. Okay. So I say df of tips is equals to sns dot load underscore of dataset, and that is, so here you don't have to let's define that whether this is CSV or Excel, right? You just write the dataset name. That's fine. That will be loaded up, right? And now I'm going to see the sample of data tips, that is some sample 5 values. That's it. So sample 5 values has been given up. That the columns are the total bills, the tips, the sex, the smoker, the date, time, and size. According to the, like the customer visits a restaurant, and what is the total bill, what's the tip, right? What is the sex, like what is the sex of the bill pair, like if it is male or female, and like smoker, yes or no, which day, time, right? The total, the number of people with him, or like anything, like okay, that is size. Okay, fine. So like this, there are a lot of various data sets over there. Okay, 1 minute. Yeah. Okay, so like if you go for like looking for the tips data set, you will be getting it to understand that this tips data set is a simple data set that consists of the observations of the tip provided in the restaurants, right? So this consists of the total bills, the tip, the sex, and all those such things, right? Okay, moving ahead. Now the first thing, like whenever you have the data set in the Seaborn, we have various features. Like we have figure styles, we have figure XS, what we have discussed in the Matplotlib, right? Similar to that, we even have in the Seaborn, right? So let's see the figure styles. I'll have to do it quick because we'll have to complete it today. So figure styles, right? Now, style. What are styles exactly? Customization, what you do in your graphics, right? So there are the figure styles we call as even figure aesthetic. Okay, so it means like you will be having a set of some principles or like some rules for various figures. Let it be any figure style or like what you talk about. So the interface what we give for manipulating our plots, our designs is called as figure style. Okay, and that we set using the set style. If I say so, we can say that the interface of figure style is given by underscore no, yeah, so you can write set underscore style. Okay, so this is the function by which we give the style names. So what exactly the style names we have? We have some 5 style names, right? And what are those style names? So we have white grid, we have black grid, dark grid. We even simple have this white, we have dark, and we have text. Okay, so these are the 5 style names. And for setting any style, what we write like set underscore of style, and then any style name you write. Let's say white. That's it. How we write the styles. Okay. So just giving you a graph, and we'll look onto the things. Okay. So let's say this is A, and this is my 1, 2, or let's say a range of 1 to 10. Okay, right? I say B, which is going to be np dot sign of A. So I'll just plot it simply, the A versus the B, and just see the plotting first. So this plot looks like going from 1 to 10, right? Like the values you can see in the plotting. But what if I just customize this by saying SNS dot set the style of the plot as dark? Did you found any changes over there? I didn't found something. Dark red, yeah. Okay, it's kind of a just a dark gray. But keeping it as a white grid will give you a white grid kind of thing. Like if you even define a text would be better different. If you define the same graph in the text, well, that's it's kind of a thing. There are various styles you can go on, like you can practice, you can see how the things accordingly, right? Then, similar to the styles of the figure, we have something called as excess style. Okay. Now, once this figure style is defined up, then we have excess style. Now, excess style is to customize the parameters for the set style. What we are doing in the set style. So, for customizing these set style, we use excess style. Excess, you know, right? What are the excess? These 1, 2, 3, 4 excess, right? So for getting the excess, for you say for getting a lot of what are the styles of the excess, you can say we write SNS dot excess underscore style. So these are the style what you can write in case of an excess, right? Excess dot face color white, excess dot head color, and some of we'll be using even, right, font and all those things. Okay, we'll go in some things. Okay, now next comes the color platelet. Color platelet, you know, right, that it can be a combination, you can say it can be a combination of various uh, colors basically. So this plays a very important role. Colors, when you talk about the colors, for any graph, colors are very important because that changes the way of how we look the graph, right? So remember, like in when like in the class 8th or ninth, when we were taught that we'll be having from class 9th the various subjects in the social, because like in the times in the social studies the book were like black and white and the images were also like a black and white, so we don't prefer to go with the black and white images most of the time, right? We go with the colors and all, right? So colors plays a very important role basically. So there are various color palettes, right? If you go in the paints in the Photoshop anywhere, right? So you'll find the RGB relations and a lot of things, right? So what exactly kind of the things are there? 265. Okay. Now Seaborn provides you a function. Okay, I think someone is there. So Seaborn provides you a function called as color palette, right? Which is used to give colors, you can say, to your plots, or adding some uh, more variations to it, right? So let's say this is color palettes. Okay. Now here the parameter you write, in case how you write up the thing in the Seaborn, right? You write SNS dot this color palette, okay, and then we write up that what is the palette, what the palette we are going to use, okay, and like by default it is none, okay, and then we define the number of colors we want, right? And that is also by default none. We have to define like if you want like, and then desat is the desaturation value of your colors what you are going to give, okay. So by default it is written as none, but it is always 6, okay, always 6 colors you will be getting by default. Desat is the proportion of the desaturation of your each color you give, right? And that is also you say by default it's none written up there. So that's the syntax basically, right? The parameters are the n colors, desat, and the palette, right? And this returns you a list of RGB tuples. When you will be getting the output, you will be getting the RGB tuples, okay, right? So let's just see one example, and then you will get to understand it more detail. So if I say just the above code, copy, copy and just paste this, run this. No, that is not callable. Okay, yeah, okay, fine. So what you can see, list of RGB tuples, right? So what this point defines you the various tuple value of various styles like deep, muted, bright, pastel, dark, colorblind, and a lot of things, right? So in various ways it define you the values basically, okay, right? So if you, so whatever the values you'll be writing, you'll be getting the results for the same, right? What do you see here? There's this one tuple, okay, 1, 2, 3, 4, 5, and 6, 7, okay, right? So now let's say you write the same thing and you say your number of colors to be 3. So see, there are some 3 tuples with the 3 colors. So these are just 1, 2, 3 just stands for the various R, G, and B colors. That's it. What is the proportion of R, what is the proportion of G, and what is the proportion of B? That's it. That is being defined here. And the saturation value, if you give your own value, it will be obviously changed up, right? Okay. Now let's see a graph, right? So, right, you can take as many, the number of colors you want. Let's say you want 20 colors. Obviously, you'll be getting a 20 tuples over there, right? You want 2 colors, so 2 tuples. That's it. Easy things. So students get confused always with this tuple values. These are exactly the saturation value of these things, right? But to plot, right, we are not getting any color now, right? We are only getting the values. But how to plot these values? For plotting up this will require a function called as palplot. Okay, palplot. So this function plots the color palette in an horizontal array, 1D array, you know, that is palplot. So it would be written as palplot. So like if I write SNS dot palplot of any color, right? So if I say this is my current platelet, right? This is my current platelet, and I'm using CR underscore of Rati. So obviously, if I have written two colors, then I would be getting only two colors, right? Similar, like if I change the values, if I say 6 colors, by default it is 6 colors. You will be seeing up. Let me write some 10 colors over there. See, so 10 colors based on the things, right? So if you write your oranges, I think it's oranges, might be a wrong spelling. Yep. So if you write oranges, then obviously your palette color will be total on the oranges. So that depends, right, guys, that how you write up the things. If I say pal plot of like just SNS dot the color palette, or if I say the palette is equals to any value you write. Like, I think that is NIPI spectral would be fine. SNS dot color palette of this. Sorry. So the various colors are there basically, right? So you'll not get any color value. So the best way to find the colors, what I know, right, in the Python, right, if you have any difficulty, you do a mistake, right? That is very nice. You do a mistake, you'll get the right results, right? Even for like if you go on the internet, you search for various things, you'll get a lot of answers, but not exactly what you are searching for, right? So what you can do is, like, let's say you are plotting something, a graph, okay? Yeah, plotting some x and y. Let's say this is x and 1 2 3 4, and let's say y, this is y, this is 2 4 6 8, right? I've given some values to this, and now this is right. So I just want to plot plt dot plot my x and y. Okay, that's a graph basically. And now I say the label is equals to x, plt dot plot the y with respect to x, and I again say the label to be y, right? And I plot this. So I get a graph over there, blue and orange, right? But no labelings. So what I can do is plt dot legend. The basic things, we have done this, right? And then plot this. So now this belongs to X, this belongs to Y. We have got that, right? Okay. Now if I say that the location equals to upper, right? So what do you see? That this is wrong something. Valid location not. Then what are the valid locations? So you have got the answers even, right? That is the best. The valid locations are best, upper right, upper left, lower right, right, and these are the locations. You can use these things, but not upper. So right, let me take as the best. That's it, done. So the best is this. If I say the like lower, I'll again get a error, right? So lower center, let's say lower center. See lower center. So values depends on like, so if you don't give any parameter on the location, obviously you'll be getting in the best one. The first priority is the best one. So you'll be getting in the best, right? That's a plot. Okay. So that's what I'm saying. Like here also, if you do any mistake in the palette, because there are a lot of palettes, you can't just remember on the things, right? So there are a lot of palettes basically. Okay. So let's say that you come with any mistakes, right? Let's say if I have made a mistake in the oranges, I made a mistake in that time also, and I made orange is not a valid palette name, right? So then what are the palette names? Like if you go for searching up, right, that is uh, color palette names in C bomb. So you will get probably a graph and one such things like these are the palette names, right? These are all the palette names. Somewhere it might be there. Okay, so these are the palette names in the Seaborn. Here you'll be only seeing like choosing color palettes and like color palettes and all the such things, right? So you make a mistake and you'll get the right answer. That's what I think, right? So I can see here the value error, right? Because these are all the color palettes what I can use from SN to winter. That's it. From A to W, these are the palettes. Let me copy up this. So this is oranges. Okay. So the color palette names are these. So you can use any of these things to see basically a value, right? A plot with some, because these all have their own uh, variations in the color, right? Let's say BWR. So if we look on for the BWR, what will be there? So BWR something looks like this. Okay, got it my points. Having any doubts, guys? Any doubts to anyone till now? I believe no. Okay, fine. So my favorite one is Vistia. I use Vistia for the most of the times, right? So that is actually a good combination. This one, that's better. Okay, fine. Moving up next. So like this, right? Let's load our data set. And we'll look on to the head of this, right? So sepal length, sepal width, petal length, petal width, and the species are been defined up, right? So like if we go for understanding the values, right? What exactly are there in the data? So what is the very first thing you do? You go first and you look for the shape. What is the shape of this data? Okay, 150 by 5, right? That is 150 rows over the 5 columns. Now if we cut off that species, because that is something which is the exactly thing, right? And right, exactly, you will also be doing a project, right, where you will be predicting the species of the whole data set, right? You'll be predicting up the species value of this whole data set over there. So if I say this array start the columns, these are the columns, and like if you want to make it in the list, I think you're better like cleared in the panda section, right? Okay. Now, in the seaborn, we have two kind of data. Yesterday, I also discussed with you. One is said as what's that name? Univariate, and bivariate. Right now, these two things are actually very different. When we talk on univariate, there are separable graphs for plotting a bivariate and univariate. So for univariate, see, we use something like for the bivariate, we use joint plot. For univariate, we use distribution plot. Things have been there, right? We'll be looking up. Okay. So the very first thing comes the distribution plot. What you see there as called as a univariate plotting. Okay, that is the very first thing, and even we call it as an histogram, right? As a histogram, basically. Okay, if I say that if we are having iris data set, and there we used dist plot, basically, I'm saying on, right? So this is dist plot. So that is used for plotting univariate values. Who's there? Oh, here it is. Suham Joshua. I call it the distribution. Here you'll be also getting a term called as KDE. Why is it not doing? Yeah, fine. So that is a use of test plot. Okay. Now let's just plot this. You'll get it understood. Test plotting. Is this any? Yeah, okay. So let's say of my iris data set, I'm going to plot the petal length, and these are the numerical values you can see, right? So petal length I'm going to plot up. That's all. So what I see is a histogram, basically, right? One of the thing is a histogram, and one line you can say that is exactly a KD, kernel density estimation, right? That is a blue line covering over the things, and that is a KDE flag. Basically, we call as. Okay, we'll be understanding what is KDE and what is its use. Okay, as a result, the representation of this, like if I say that I don't want a KDE, I can write KD is equals to false. So I'll be only getting the histogram there in this case, right? The petal length, the histogram of the petal length. But because if I look onto the petal length, if this is iris, and if I go to the petal length dot the values, I'll find it starting from 1.4 and ending at, oh, it's 5.0. No. I could see is it ending in 6 point something, like nearly to 7. Okay, let's do one thing. Let's say np dot sort this values. Yep. So starting from 1 and it's going to 6.9, right? That's clear. Okay. So it is having a values from 1 to 6.9, and that's being displayed in an histogram format, right? You can even write the colors, right? If you, in a graph, you want to write the color, it's a red or whatever the color you want, green, pink, anything, right? So you can plot it accordingly. So that's a histogram. Basically, we saw yesterday also that how histogram looks like, right? And for making a KDE, now we'll be discussing about what is KDE once again. sorry, yeah. So you have various methods. You can write G, green, G, anything would work. Like if you write G, yellow, greens, oranges, whatever being there, RGB or color non formats. Okay. P, still not working. Cool, let it be. Let's discuss further. Okay. So you can give set styles if you want in this graph, right? What we discussed. You can apply. So you don't press learn and keep it there. Try to implement those things. So set the style and let's say this is white grid. Okay. Could be dark grid. Yeah. See it's dark grid and the values over there accordingly. Alright. I have made KD equals false. If I say KD is to equals true, we'll be getting something else, right? So what exactly is a KD? And in the test plot, so there are various features, there are various parameters in the test plot. What are the parameters? What are those parameters? So you can take inside KDE, you can take give any histogram value, like hist equals to whatever you want, right? True or false, like a boolean value, true or false. So by default it's true, right? And then you can write the KDE equals to true or false by default. This is also true, right? Then you can pass your color. The major things I am talking about, right? You can give your color, that's very important, and that's just the things you can take on. Okay. So these are the values, you say the parameters and all such the things. Okay. So here we have used KDE the color. Now I'm going to see, let you see that what exactly is the kind of hist equals to true. Okay. So if I say hist equals to true, I'm getting a histogram. That's it, right? But what if I say hist equals false? Nothing is being plotted up because even I have said the KDE is also to be false. So I could not see anything, right? The KDE is also not given up there. If I say the KDE to be true, we'll see the KDE, not the histogram, right? Okay, understanding of this. So we'll discuss like what is KDE now, right? So this is a way just to estimate the probability density function of any continuous random variable. Okay, any continuous random variable. You look onto your graph, right? One second. Let me give you just a scatter plot of this thing. No, scatter would not work. Uh, count plot will also not work. Mm, all right, let's just see. Just see the distribution even, right? If we got to give the values to be true. What do you see from where this is taking up, right? That is getting just an estimated value, right? And this is used for non-parametric analysis. Okay, so that is like if you set the hist value and or like you will yield the kernel density plottings. This can be done. So dest plot is just used to visualize the parametric distribution of any data set. Okay, like if you have values, many a time what happens, you need to compare it with something to get a plotting, right? If we talk about like going with a scatter plot or any such things, what we do is we used to go and compare with something, like even we go for histograms, we could make it very easily, right? That is working with one variable called as univariate. Okay, but when we work with a bivariate, then we don't work with a dest plot, then we work with two. For bivariate we work with a joint plot. Okay, and even every other function like you say, so bivariate means that you will be getting at a time, you will be getting two graphs over there, right? At a time as the two graphs there, including the KDEs and all, right? We're getting the things over there. but you work with the two parameters in a bivariate. So this is used to determine the relation between two variables up there. Like you talk about bar plot, you talk about the pie chart, more than two are there, right? Okay. So when we work with the two data, we say it's as a kind of a bivariate function. Right. Okay. I think this is clear, right? So you can make it the things accordingly. So these are the values. Let me make it up there. This, yeah. Okay. Now you can say that SNS dot. If let me show you one more thing. That in the disk plot, you can make like colors and wall. What I'm talking about is rs equals as, let's say, for petal length event. Okay. This time I'm not making carries and I'll like not giving the things over there. So I'll write the histogram to be false, and you see the things accordingly, right? And I'll set the styles even. Uh, yeah. So I could see even these styles, or if I say white grid, a dark grid. Okay, fine, let it be. Okay. So you get the things accordingly, like what you said. Even the width and all you can keep accordingly to you. Alright, so moving up next to the joint plot, that is plotting based on a bivariate distribution. Okay. So here you basically work with more than one feature, that is two features, right? Or you say with the two columns, with the two variables you talk about. Okay. So this is just to use to find the relationship between two variables, and uh, like it mainly deals with like how one variable is behaving with respect to the other. That's how, right? So the best way to analyze any bivariate distribution is by using the joint plot uh, graph, right? The joint plot function. So this joint plot creates a multi-panel figure that projects the bivariate relationship between the two variables. Like in the univariate, one each variable on every separate axis, like that, right? So in bivariate, you have one kind we call as a scatter plotting, right? Because there we deal with the two, you say the two variables, right? The scatter plot, the count plot is one. Okay, so we deal with the various things, right? Over there, you talk about the scatter plotting, you talk about the strip plot, you talk about the box plot, and you even talk about the bar plots. All those things where we deal with the two variables, we call it as child plot. Okay, sorry, the bivariate things, right? Okay, let's just plot this. Let's say that we are going to use the joint plot, and as I said, you could say this joint plots creates a multi-panel figure. Okay, I think you can write as C1 of, yeah. So see, like I think this will be giving you something, right? So parameters are x and y. So you took some take basically two parameters, and then you define the data, and then the kind, whether this is a scatter graph, hexagon plot, and what kind of plotting you are using, the colors, the height, the ratios, and it's draw a plot of two variables with bivariate and unvariate graph. Okay, so one will be an unvariate graph and the another will be a bivariate. That is the two graph you'll be having up, and things are there. Okay, various things are there. You can go with this, or okay, this is also using this. Say petal width will be also using this thing, right? Not with these all parameters. We'll be using up with this bit one. Okay, fine. So let's plot this SNS dot joint plot. Let me delete this. So joint plot and then give the two variable names. So one will be the petal length and other would be the petal width. Okay, and then you define your data from which kind of data you want this to be plotted up, and that's the graph. Yeah, so we have got the values between the two features. We say like in machine learning language we say it as features, petal length and petal width. Now what these have basically, right? What this have, if I say np dot sort the ef underscore of iris dot the petal length dot the values dot the max minus one of the bounds. Okay, fine. So I want to find the 0th and the -1. So sorting is giving up some values. Okay, if I remove this. So PL.max, PL.min. Similarly, the PW.max and PW.min. This has no material. Oh shit. Fools. So 4 points, some results. So this is going from 1.0 to 6.9, and you can go, you can see the values going from 1.0 to 6.9, right? And this side it's going from 1.0 to 2.5, and you can see it's going from 1.0 to 2.5. And the next half, on the right side, you say, at the back side, what you say is the histogram you are seeing for the two data, like one in the x-axis, another in the y-axis, and here you have seen just a scatter plot. Scatter plot, you mean, right? These are the points. If you go for the joint line plottings, you'll be seeing that these are covering from these all areas. So that's basically a scatter plot of this all. If I say SNS dot scatter plot of all these things. So you'll get a scatter plotting. Basically, this is exactly what is being demonstrated here. But the thing is, you are getting a scatter plot as well as a histogram there. That is what is called as by working with a joint plot, multi-panel figure. Okay. Now, like here, if I say that, like in this thing, you can't just see which one is of which species, because with the petal length and petal width, what we are searching for, we are searching for the species points basically. If I say it according to the species, we'll find it better visualization. So now we can see that these green points are of Virginica, these orange point of versicolors, and these blue points are of Setosa. We'll be covering up those things, right? Okay, and okay, so let's deal with this. So here, one parameters you saw was the kind. If I say hexabin plotting, obviously I'm going to see something as an hexabin, right? If I say strip plot, it will be what is there. Okay, so you can take scatter, you can take regression plotting, you can take residual plotting, you can take KDE, or you can take hexagonal. So let's copy. That's what I say. You make a mistake, you'll get the answers. So type, or let's say kind. Kind could be taken as this. So let's say if we talk for the regression plottings. So regression letters like a machine learning modeling I'm talking about. There you get a regression line for the best fit line where we could cover all the points. See, if we talk about in the machine learning, we'll look on that what is exactly a regression thing. So what is being done? See, this 2.5 has been like extended to 3, and this 6.9 or 7 values has been extended to 8, and we are getting just a point, like a graph where we can see a line passing through this with covering all the data. Like every point is very closely packed with this line. We say that is the main motto of any regression model, to make such lines that could pass over the points, uh, which could reduce the distance between them, right? uh, we'll be looking on those things, right? Okay, so that is like exactly a joint plot works like. Then you can even give your colors. So I guess I think would be getting the results accordingly. Yeah, right. That is exactly the joint plot. Okay, clear. All right, moving next. Meanwhile, if you have any doubts, you can ask it anytime, right? Okay. Having any difficulty and understanding? Oh no, someone is waiting up there. Having any difficulty in understanding in things? Anyone? At least that is like moving up very quite fast, but still, hope up you will get to understand the things. Okay. Anyone wants to ask anything? No. All right. Right. So next is our pair plotting. Right. So if I look onto the pair plot, I think that would be there in the axis grids now. Okay. Here. There's the pair plot. Yeah, here. So pair plot, you can see it plots pairwise bivariate distribution. Now, see, these statements are like just like a complexity statement, right? So what you will get is like, let's say that you have, what are the column you are having? If you look onto the columns, what are the columns you are having? This is 1, 2, 3, 4, 5. Okay. Let's say, let's talk about something mathematics. If I have a coin head and tail, sorry, I have a coin which sides are head and tail, right? What is the possibilities? What are the values I could see if I toss this? What could be the outcome? Either head or either tail, right? What, let's say if I have two coins and I'm having now in both the coins head tail and head tail. What are the possibilities? What would be the values? Answer quick, yeah. These are the basic questions.
Head or tail?
So 50-50 probability will be there.
Head.
So what exactly we do? What for finding the probability, what we do is, okay, with this one could come, with this one could come, like there could be head, this could be tail, this could be tail, this could be head, or like both could be headed, this could be tail, right? We do the combinations basically.
Yep.
So here also what happens,
Yes,
like whatever the columns you are having up, when you go with the pair plotting, what happens, every column is being compared with one column, and you will be getting a graph of this column with compared to every columns. Like let me show you, you'll see it. So this is pair plotting, pair plot. Okay, it's fine. Nothing written up there. Plot pairwise by varied distributions. Okay, pairwise by varied distribution. Okay, so SNS dot pair plot, and you write the data name basically, not data name, data frame name, and wait for just 5-10 seconds. Okay, more 5 seconds. Yep, got the result. So here what I'm seeing is like sepal length is being there, right? Think it as like for a head and tail, right? So this is one sepal length, and this sepal length is compared with, see, this is the y-axis. What is being compared? Sepal length versus sepal length, first graph. Okay, sepal length versus sepal width, second graph. Sepal length versus the petal length, and sepal length versus the petal width. So all the numerical values will be just plotted up, right? So every column will be compared with every other column. See, sepal length, sepal width, petal length, petal width, petal width, petal length, sepal width, and sepal length. Every 4 will be compared with every 4, and ultimately you'll be getting 16 graphs, right? But we cannot compare up the things here. Can you just discriminate that what is the Setosa category, what is the Virginica category, right? We cannot just separate this, right? Right. So what we can do is we can give a hue semantic here. We can give a labeling. We say, right? We can say the labeling hue semantic as the species that we want to look on the graph with the species. And okay, I'll show you this in the next graph. Now, what are the parameters here? Here we say that we are going to plot this iris. Okay, the very first thing is he's giving hue semantic as per the species, and then we say the diagonal kind. What the diagonals? What we are getting up here now? What we are getting, all these diagonals, like these are the things which are compared with their own columns. Like sepal length when compared with the sepal length will be getting a histogram. Okay, sepal width when compared with the sepal width will be getting an histogram, and so does the thing, the diagonals. Okay, so I say the diagonals kind to be a KDE, right? You know, the KDE obviously you'll be getting up now, just a line kind of thing, what you have seen in the previous things, right? A density estimation, probability things, and then I say the kind, what the values I'm looking on here, as if I say a regression, it'll again see the things, different values, okay? And here if I say the palette what is being I'm going to use is, like I say the VCR to be used, and I run this. Let's see what comes. This time you'll be getting a colorful graph, and your total view for the graph will be changed. Like if you go for looking on these things like a black and white thing, and they'll be getting any errors. Okay. Now we are plotting, actually we have plotted a regression line, so obviously we'll be seeing a graph as well, like things. Okay, so these are all the KDE what I was searching for, and these are all the regression line which could pass up the values very closely packed up. Like there is a line which could like go with every of the values. Okay, and you can even save this. You know, you can even save this, right? You have, for saving up the things, you can make it a transparent image, like a PNG format, right? For saving any file, like use PNG. Like if I want to make a transparent one, let me copy this and let's paste it here. So not this, it would be an iris underscore of regression KD. Okay, let's run this. You'll get a graph. Come fast. Let's see our data set. Yeah, got it one. Still processing. Completed, completed, completed. See your graph. Species have been given. The light belongs to the setosa, the versicolor belongs to this, and you can even download this, right? Download from here, and then you can even share to anyone, right? These are now a PNG graphs, right? These are the PNG one right now. Like if I say in a blank document, if I just need to insert this like picture from file, downloads, and that's a graph you could see, right? It's easy how you make things, download and keep on working, right? Okay, fine. So that is like one kind of a graph, right? Similar to this, if we change up the kinds, what we saw that there are regression plottings there wherever where it went. Yeah, regression plotting, scatter plotting, residual plottings, KDE plottings, hexagon plottings, right? So if in the whole graph you want only the KDE plots, whole graph you want the KDE. If this will, you will be getting very fast, right? Hey, in some like 2 to 5 seconds. 1, 2, 3, 4, 5. Oh no, we are late. Yep. See, it's quietly a complete blank thing. Okay. So only when you go for the KDE, because see, one diagonal can only be the KDE. Like every values cannot be the KDE. Okay. Got my points. See, you have got nothing to be there. Like it is there, but with some like colors, what you can't see. So you can make a change over there. Instead of the KDE, you can write it as scatter, and that will be the same things, but it will be in some undistributed way, right? It will not be a like of a plotting of a regression line. What you have seen, the closely packed values, you'll not see this thing. You'll see the values exactly like this, right? In some shattered ways, in like here. See, okay, that is the working of a pair plot. I think that is clear, right? You can define the axis and what like all the things you want. Okay, so that is how we work. All right, coming next. Okay, let's say I have some weights and height of any person, or let's go to this BMI. Oh, calculators are there. Do we have any values for that? Just want to show a graph, but not want to write the values. No, 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 no. Weights, age, men, kg, years, woman. Oh no, that is being in the inches. Interest. Is this copyable? Oh god. Alright, leave it. I'll have to do. Let's say there are weights 62, 64, 78, 65, 89, 45, 67, 46, and 67. 67 has been quite time. 60, 98, no, 98 is quite big. 88, 87, 50, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10. Okay, similar to this, I take the heights. Now height could be, let's say, 120, 150, 167, 156, 187, quite big, 167, 120 is quite less, 154, 178, 161, 163, 180. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 157, 149. The values. So scatter plot. Now inside the scatter plot, you get two kind of plottings: strip plot and swarm plot. Okay, right? So we'll go on that too. We'll see of the things. In case you have to define your own two parameters, no, not exactly the parameters, the variables, like x is equals to the weight, the y is equals to the height, right? And there is no such data right now. The color you want, you can take it's orange. Okay, and orange is not defined. Oh, see the values, right? So accordingly, the height and weight, what you see in the scatter kind of thing, right? Let me show you the help of this. SNS dot scatter plot, and there I think there are a lot of parameters. Style, okay, and the data, the palettes. Basically, the palette is being given, right? Which palette you want to use. Like in case of the color, you say the palette. So there you have to change the names. And writing oranges is giving blue. What is that going on? Okay, so you have bins, you have markers, right? Markers also, yeah. One more thing. Remembering all the parameters are like quite big thing. Basically, if I'm going with a one such values, then obviously, so palette is there. Can be a name, can be a list. The colors you want to define when you have more than one particular thing to be displayed up there. Can you go with that? And there are a lot of things. So you can take help from there, right? Always try to do something new, right? Don't just stuck up with the things what we got. Alright, greens. What is there not working? Okay, fine. Clear color specification to see books. Yeah. So under the scatter there was two kinds, strip and swarm. So what strip does, the only basic difference is just plot the data with one categorical value and with overlapping points. With overlapping point means Let me show. You will be getting the plotting where the data will be just overlapping one another point, right? That is one another data point. You'll be getting all these are the data points basically, right? So this will be overlapping this, and that's exactly a kind of you will see it is like a good plotting, but obviously different kind of things will be there. So SNS dot the strip plot, you'll see the difference. The values would be same. It is not a difference, but the customization would be different. So I want to plot the species, let's say. On the y-axis, I want to plot the petal length, and I say the data to be taken from TF of IS. So you'll see a graph. See, this is the graph. Okay. Okay, fine. That would be. All right. So what you can see, the points is overlapping all of the points. So we have to remove this. So this works with the categorical scatter plotting with non-overlapping points. And when we talk about non-overlapping points, this means that now if we say that copying this and pasting this without like don't want to write the scalings and swarm plot, yeah. So can you see any overlapping in the data points? No, right? The values remain still the same, going from 1 to 2, like from 0 to something 2.5. See the same things over there. Okay, with the variations. With this also, it remains from 3 to 5. The values remains from 3 to 5, but not overlapped. Here values goes from 4.5 to like 7 something, 6.7 I think. Yeah, and here also it goes from 4.5 to 6.7 and all. Okay, that's the thing. Similar to this, there comes the box plot. We'll go with this one as the last one, and then we'll be continued with the next thing tomorrow, and day after tomorrow. Okay. So box plot, what is that? Right? What is the box plotting? So this gives you a range of a plot. Range, that means it will make a line even that from where the values have been started and where it is being ending. Right? So this is a method for graphically depicting groups or the numerical datas by their quartiles. And when we say quartiles, we learn in the R programming, when you will be learning R, whenever you learn R in your life, right? So you'll see that there we work with the quartiles, not with the ranges. We say it as quartiles. Okay. So like in the box plot, what is that? If I say SN, like same thing, I'm plotting with the box plot. That's it. Right? And let's make big because this will be a small thing, but because by default you'll get a small figure in the box plot always. So let's make it quite big. So fixed size is by 10 by 5, and then you plot the box, the species, and okay. So here you don't have to define up the things, you just write up the data frame name and you say the orient, vertical or horizontal. Let's say if I'm plotting horizontal, you'll be getting all the columns, what is there, unsupported type for the float and the string. You get even a quite big error also there. Okay. Data, so I think that is box plot of data df of virus. Okay, fine. Then orient is equals to this. That's also fine. What is the problem? Wow, this is working now. Okay, fine. So what you see is there is a plotting which goes from 0 point some points to 2 point something. These are the ranges. Most of the values lies with this area. So you're getting the things. Okay. Otherwise, you can go with health. That's it there. No poddings and all. Okay. See, on a quantitative data with categories, so X and Y you can also define data order, hue order, orient, palette, saturation, width, dots, various things are there. Every parameter description is being given over there. We can go with all of the things. Next, we'll be seeing the cat plot, violin plot, these things, right? So violin plot, in the violin plot, you'll exactly getting a shape that is same as the violin. And the cat plot, you're looking at something different, right? Okay, fine. So that's the thing how we do the plotting. So explore the help analysis and all. So tomorrow is a holiday, right? So complete up that all the graphs what we see, what we have seen till now, right? Go with the help module of all the graphs, study the graphs deeply, and then you have any doubts you can come and ask on Monday. Okay, right?